So a couple important announcements. We sent out an email last night about a problem with JCrater. And this is something that people are running into with homework 2. In particular, JCrater in the labs will pop up a black window and actually run your program in it. And when it's all done, it'll say press any key to continue. And a lot of people are using JCrater at home. It actually does it inside a JCrater window. So it's a white window at the bottom of JCrater. And somewhere between JCrater and the scanner class, and the scanner class in Java is a bit finicky to begin with, somewhere between the two of those, something isn't working right. In particular, when you try to get all your strings in for the vector homework, which is homework 2, and you do a whole series of .next calls, it's not working. So we sent out instructions as to how to tell your current version of JCrater to use the black window. That should fix it. In particular, if you're not sure how to make those changes or not sure if they apply to you, please feel free to swing by office hours. Myself or any of the TAs are happy to help. But if you don't switch it over, you're not going to be able to test your homework 2 properly. And apparently that was so important that it's twice there. So the second homework is out. It's what we talked about last time. It's the vector homework. Lab 1 grades were returned last night. I expect Lab 2 grades to be returned either today or tomorrow. And from now on, most assignments will be returned within 1 week, give or take a day or two. Of course, 1 week after the labs aren't finished by the 101E students until the Sunday after you guys do it in Thursday lab session. So it's probably about a week and a half after that lab session that you'll get the lab grades back. But generally, I'm pretty good about keeping on top of that. And essentially, you'll receive those emails like you did last night. If you did not receive an email, then it's probably caught in your spam filter. Or maybe, actually, that's not always the case because the computer science department has a tendency to lose emails every now and then. So maybe like none of them are sent out. Speaking of which, I'm really behind on my emails. I have about 250 in my inbox. If you sent me something recently and it's important, it needs a reply, come speak to me. I will get through them, I promise. I just don't promise it's going to be any time very soon. And as we talked about the course project, I'm going to be presenting a couple ideas. We have it narrowed down to about 4 ideas for the course project. We might have to eliminate 1 or 2 of those choices. We'll be presenting, or I'll be presenting those on Wednesday, and then everyone gets to vote on Thursday as to which one they'd like to do, or which one of them they prefer. Questions, comments, concerns? Okay. So last time we had started talking, we had talked about references, and today's lecture is going to continue talking about references. And in that context, we're going to be giving some examples about using objects and calling methods out of objects, creating new objects, etc., etc. I would expect that at the end of today, we're going to get through most of the Chapter 2 material. We may have a little bit left on Wednesday. Once we're finished with that, obviously, it's Chapter 3, which is ifs and decisions. And that's going to be the next, well, an upcoming homework, obviously, is going to be on ifs and decisions. So that's a quick review of last time. Let's say we have this. String word 1 equals luminous, string word 2 equals graceful. Keep in mind that even though there is no new string there, we are still creating a new string object. Java allows us to have this shortcut for strings and for strings only. So initially after the first 2 lines, string word 1 equals luminous, string word 2 equals graceful, that's what memory looks like. Remember that when we're creating an object, Java does a number of things. It creates a reference, which is called word 1, because that's what we called it. It creates the object itself, which is a string object with the text luminous. And it makes the reference point to the object. It does 1 or 2 other things that we'll see in a bit. And then, lastly, when we say word 1 equals word 2, remember that that's an assignment. That's going to copy whatever on the right over to whatever on the left. So the value in word 2 is going to be copied into word 1. But keep in mind that since we're dealing with objects, and therefore references, the value in word 2 is a memory address. We don't know the exact value of that memory address, but that memory address is wherever this object is in memory. So that value is copied over, and now both word 1 and word 2 have the same memory address, or same reference, and are pointing to the same object. This then gets garbage collected. Remember that garbage collection means that anytime you have an object and nothing is pointing or referring to that object, Java just makes it disappear. It just goes away. We never have to worry about it again. We no longer know where that object is in memory, because we used to keep track of where it was in memory in here, but now we just overwrote that with something else. So sitting off somewhere in memory is a string object called luminous, and Java is going to get rid of it. Right. There we go. Java got rid of it. So we've been creating scanner objects in most of the programs we've been seeing so far. But until now, we've kind of hid the whole scanner object creation. I just said, use this line. We'll talk about it next. Well, the first line, scanner standard in equals new scanner system.in, that's creating, again, a standard in reference and a scanner object. And this is sort of the shortcut version of the scanner object. It has a cute little picture of a keyboard to let you know that it's going to read in something from the keyboard. Again, there's a big sort of formal box notation for how to represent objects, but I don't really have enough space on a lot of the slides. We then print out, enter your account name, and the next line, string of response equals standard in.next. So standard in is this reference. Dot means follow the pointer, and next means I'm going to read in a string, or I'm going to call the next method from that scanner object. Well, the next method will read in a string from the keyboard, and we then have string response, which is the string artiste. I didn't make up this example. And again, we have response to the reference pointing to some string object. Now, purposely going over this in a fair amount of detail because I want to both review it and make sure that it's more solid than it was last time in terms of what's happening with the objects and what's happening with the references. So if we were to say string alphabet equals A, B, C, D all the way to Z, this is one way we might represent it. And this is a shorthand version that I've shown before. In reality, Java looks at it kind of like that. And the difference here is that, notice that we have, again, the same 26 letters. But they're sort of set into cells, if you will, where this is 0, 1, 2, 3, all the way up to 25. Keep in mind that although there are 26 letters in the string, they're numbered 0 through 25.
Now, if you have a space somewhere in that string, will it save a space in one of the little boxes too?
Yes. The question was is that if I have a space, will it save a space in one of those boxes as well? And I don't know. If that was my space, okay, I guess I didn't color match quite so well. Then yes, the space takes up a box or two. Or, I mean, you could have 3 spaces and it takes up 3 successive boxes. So now let's look at this code. We create the same string object we did on the previous slide, and we call a series of methods out of that string object. And of course, the question that we're going to look at is what are the values of C1, C2, and C3. So after the first line, again, we have this. It creates the reference alphabet. It creates the object, A, B, C, D, E, F, G, all the way to Z. And it makes the reference point to that particular object. So when you're looking at this car at, that returns the character at a specific position. So let's look at C3. That's going to return the character at index 2. Remember, since it starts from 0, index 2 is actually the 3rd character, hence why it's C. And car at 9 is going to return the character at index 9, or the 10th character, which is J. And then that's going to return the character at index, or at position 15, or index 15, which is the 16th character, which is P. Only have my first 5 letters memorized, apparently. And again, when we say alphabet.car at 2, that's saying start at the alphabet reference. Dot means follow, dot means follow the pointer, and then call the car at method out of that object. So as I mentioned, the string class has probably 100 methods or so. We'll use maybe a half dozen, it's maybe as many as a dozen this semester. There's a lot there that are methods that are very rarely used. But this next method, called value of, that will convert something into a string. So here, the first couple lines create an integer, a double, and a character. These are all variables. No references involved. Int, double, and char are primitive types, and v1, v2, and v3 are the variables. So now I have three variables with values -12, 3.14, and the character a. I say string s1 equals string.value of v1. What that's going to do, the value of method, is going to take whatever is passed in as a parameter, in this case v1, which is -12, and it's going to give you back a string. In particular, that string will have three characters, a dash, a 1, and a 2. And it'll look like this. S1 is a reference to a string that has three characters, a 2, a 1, and a dash. Draw the order, of course. String S2 equals string.value of v2. There I'm sending into the value of method a double that's 3.14. So S2 is going to be a string that has four characters, a 3, a period, a 1, and a 4. And then similarly for S3. There we have a string with one character, that character happening to be A. So something is very different about this. You'll notice that when we're calling these methods, we're saying string dot value of instead of s dot value of. So here, we're actually listing the class. And we're saying from the class, call this method. I'm actually going to ignore exactly why that's happening for now. I want you to be, there's a reason I'm mentioning it. We are going to talk about this. This gets involved in a static versus non-static discussion, which is something we won't see until about halfway through the semester. But the thing I want you to keep in mind is that sometimes when you call methods, you say class name dot method name. Math dot sign. We're saying from the math class, call the sign method. System dot out dot println. From the system class, do something. So it kind of blurs what an object is and what a class is. The reason I mentioned this is I want you to keep in mind that when you're calling certain methods, such as value of, you should say string.value of. Why we do all this will be made crystal clear, but about a month from now. This is one of the things I actually don't like about Java, is there's so much stuff that I don't really have to say, you'll see later, you'll see later. I promise you we'll get to that. I have a great slide set on exactly that. So we talked about final variables. And a final variable, in addition to being all caps, and the reason it's all caps is this way when you're looking through code, you can easily tell what's final and what's not. This is what representation looks like. And again, this is how we draw this out in memory. I'm sorry, draw it out on the slide. Notice that what is final here is the reference. This value in here can never be changed. It's final. It's constant. It will always, always, always point to this particular object for the entire length of its life, like 10 milliseconds. Same thing here. Warning will always point to this particular object. So we can never change the object that it points. I'm sorry, we can never change where the reference points. Turns out, as we're going to see a bit later, we can actually change the object. So it will always point to this object, but we can modify the object. We just can't modify what this points to. More on that in a couple slides. But this is the representation. And the thing to keep in mind from this slide is that when we declare something final, we are saying that the reference is final. Right, which is pretty much everything I just said. Okay. So, of course, I wanted to start off early by demotivating all of you. Delusions. Read that. There is no greater joy than soaring high on the winds of your dreams, except maybe the joy of watching a dreamer who has nowhere to land but in the ocean of reality. Demotivation. Sometimes the best solution to morale problems is just to fire all of the unhappy people. You notice the demotivator sitting in the back. Dare to slack. When birds fly in the right formation, they need to exert only half the effort. Even in nature, teamwork results in collective laziness. You're not allowed to apply this to this course.
But we're in a big enough group, aren't we?
No, you're not. Disloyalty. There comes a time when every team must learn to make individual sacrifices. You know, they were probably trying to rescue him, and of course, a different caption on the bottom. Okay, so let's talk about our rectangle object. We've talked about this before. We create 4 integer variables, x, y, width, and height. And then we create a new rectangle. In particular, you'll notice that when we create the new rectangle, we're putting 4 values in between the parentheses. New rectangle, x, y, width, height. We are creating a new object there, a new rectangle object, R. And we're telling it how to create it. It's going to be a rectangle at position 3, 4. And it's going to be 5 units wide and 2 units tall. Maybe they're pixels, maybe they're feet. I'm kind of ignoring that now. But notice that the values that I have put here are telling the rectangle how to create itself. They're parameters that allow us to create a rectangle according to our specifications. This is the position, this is the dimensions. And this is what memory looks like. X, Y, width, and height are here, which are the ones that we've declared. And this is a shorthand view of our rectangle. Again, I could do the full view, but I'm kind of running out of space. And it's a rectangle. Anytime we do the position, that just means the upper left corner. So the upper left corner is at 3, 4. And then it's 5 units wide and 2 units tall. So that's sort of shorthand notation I'll be using on the next couple slides.
What is the origin
So the question was, where is the origin? Usually on a screen, at least as far as we're going to be concerned, this is the origin. And it goes to positive x that way and positive y that way, which is flipped from the normal Cartesian coordinates we're used to. As far as at least these slides are concerned, it actually doesn't matter much where the origin is, but we're going to show an example of a car class a couple slide sets from now. We will talk more about the origin, but 0, 0 is the upper left, because on your computer screen, that's 0, 0, and it moves positive y vertically down and positive x horizontally over. So what if I was to do this? Final rectangle block equals new rectangle, and here I give it some values. So that first line creates my rectangle. Its upper left corner is at 6, 9, and it's 4 units wide and 2 units tall. And I say block.setLocation 1, 4. But notice that block is final. What is final is this reference. This reference will always, always, always be pointing to this object. But I can tell the object to do something. And when I say block.setLocation 1, 4, and then resize 8, 3, so set location changes 6, 9, and resize will change 4 and 2. And what's happening there is I'm still calling a method on that object. And what's going to change is these values here. So the reference still points to the same spot in memory. Where this rectangle was before is the same position in memory that it is now. The difference is that the values of that rectangle at that spot in memory have changed. So this is what I mean when I say that when you declare an object final, what is final is the reference, not what it points to. So we cannot make block point somewhere else. We can't say block equals new rectangle. I mean, basically after we create it, we can't make block point to some new rectangle. But we can change what's actually at that position in memory. And we do that by calling these methods. From start at block, period means follow the pointer. Out of this object, I'm going to call set location, which is going to modify 6, 9 became 1, 4. From block, period means follow the pointer. I'm going to call resize 8, 3, and whatever values were there before are now 8 and 3.
So, okay, just so that I'm not getting confused. So, like, if block was just like an integer, that was final. And later on, if we did like int equals and then another number, would that change it?
So if I was to say, so when we're dealing with integers, of course we're dealing with types, and they're not references. If I was to say final int x equals 3, and then somewhere later I say x equals 4, I'm trying to change what's final, right? Because it creates some variable x. We have our little padlock. I can't draw for my life. And it's given value 3.
We can't change that.
Right. Java will actually not even compile this. It will tell you that variable x is final and therefore can't be changed, or some other equally semi-cryptic error message. So it won't actually allow you to change this.
But if it's a string, can you change it?
Well, so the question is, if it's a string, can you change it? Strings are a very special class in Java, and they're treated differently than every other class. So I actually would prefer not to answer that, because I want you to understand how it works for every class in Java other than strings. Strings are strings and arrays, and we're going to see arrays later, are special cases, and Java treats them differently than every other object. In general, the reference is final, so we'll always point to this memory address. But what's at that memory address can be mutated or changed. In particular, the 6.9 became 1.4, and the 4.2 became 8.3. Does that help, other than the fact I've completely avoided your question?
Sounds like you're very political.
Great. I'm practicing.
Regarding block, does that mean that you're basically not allowing unchosen numbers to be used?
You're not allowing chosen numbers to be used?
Like up there, you're not allowing the dimension of 8 and 3 when you put block.
Well, at this point, so here, when you say block.resize 8.3, you're changing the values in this object to 8 and 3. So you are allowing them to be used. I'll actually get to that right after class, if that's all right. Okay, other questions on this? How many people felt, I'll get you in a sec, how many people feel they sort of understand finals and, I haven't even said what it is yet, people are like, I understand, finals and references. Okay, question.
With the x equals 3, do you say like x equals 3 plus plus, and would that make it into a 4 thing?
The question is, could you have said here x equals 3 plus plus? I don't think so. Although, I'll be quite honest in that, I'm not sure. I have never seen a plus plus used in anything other than a variable. Because a plus plus does two things, right? It adds 1 to it, and it changes the value in memory, and then also gives you a next higher value. So you could say 3 plus 1, right? And that would make it equal to 4. You could not say x plus plus here, because again, you're trying to change the value. All right. We're going to see another couple examples of this very shortly. So here we have a series of a couple strings we've created, 4 of them, and we call a whole slew of methods. So string s equals Halloween. And again, I'm using the sort of shorthand version. S is a string object. I'm sorry, S is a reference pointing to a string object called Halloween. T equals Groundhog Day, and U equals May Day. So string B equals S dot substring 0, 6. So we start at S. So this is the bigger version of the string. We start at S, period means follow the pointer. And then we're going to call the substring method out of this object. So the substring method that takes in 0, 6, well, this is Halloween. So 0, 6 is going to give us a new string, hollow. And then we have that string V is the string hollow. All right, let's shrink that down again. X equals t dot index of day, 0. So we're doing out a string t, so we'll expand it to show the full version. T, period means follow the reference. It's going to call index of out of this particular object. It's going to look for day starting at 0, which is the beginning of the string. Well, Groundhog Day, that's going to return 10? Yes, returns 10. So we now have an integer or an variable that has value 10. Shrink that down. Int y equals u dot index of day. So that's u. Again, we start at u. Period means follow the reference. It's going to call index of out of this object. And it's going to look for day, which is going to return 4. So now we have an int variable y that has value 4. S equals t. So what that's going to do is, or S is assigned the value in t. T is the address of Groundhog Day. That value is going to be copied into S, and then both S and T point to the same object. Halloween then gets garbage collected away. Nothing points to it, it just disappears. U equals null. This U here is going to point to nothing specifically, represented by the ground symbol from electronics. And then May Day also gets garbage collected away. How many people felt they understood this slide? Okay, I'm seeing a good number of hands. So let's look at that again. But now, oh, question?
Yeah, when you have day, 0, isn't that just the same thing as day? Isn't they both start at the beginning?
Yes. So the question was, what's the difference between day, 0 and just day? In that case, if you don't have an integer after the string you're looking for, in index of, it starts at the beginning. And if you specify 0, it starts at the beginning. So in this case, they are the same. The reason I brought them up is one of the things we're going to talk about in about a week or so is the fact that you can have one method that takes in, like the index of method takes in different amounts of parameters. So I've sort of been mysteriously and subtly putting them in there. But yes, they do the same thing whether there's a 0 or not. You could do 5, and then it would act differently. But I just, basically that's in there to show that this index of method can operate with one parameter or two. And that's something we're going to be coming back to, I don't know, week, maybe. So let's look at this code. And the difference here is, the only difference is what's yellow. I've said final string u equals Mayday. So it's now final. And essentially, it goes through the same steps as the previous slide. We just execute S equals T, and now both S and T point to Groundhog Day. So all the steps previously were the exact same on the previous slide, nothing changed. Of course, U now has a pretty little padlock symbol in there to show that the reference cannot be changed. And here we try to say U equals null. And when we say U equals null, Java's realizing that you are trying to assign a value to a reference that is final. And Java's not going to like it. So it's going to give you an error saying Java cannot assign a value to final variable U. And that's going to happen anytime that you try to, I'm sorry, give me 1 second. Anytime you try to assign a value to something that is final, you're going to get a similar response. Cannot assign a value to final variable. It basically means U can never be changed, and here you're trying to do it. Yes?
If we said T equals S instead, with both arrows going to Halloween and Groundhog Day would be garbage?
Exactly. The question was, if we said T equals S instead of S equals T, then both arrows would point to Halloween, and then Groundhog Day would be garbage collected. So let's look at rectangle. Oh, question?
Yeah, so in the previous slide, if I entered U, what would happen to it?
If you did what?
If I entered U, like when it try and get you to come up with like, is there zeros in that?
Oh, if you try to print it? If you try to print a null reference, Java will just print out null. If you try to say you dot something, Java will just crash, or it'll stop executing and say null pointer exception. You can choose first. I'll get you in a second.
Why does B that points to auto still exist when it's got Halloween?
The question was, why does this still exist when this disappeared? Once at this line here, there we go. That line there, that creates a new string object, V, which points to hollow, right? Because, there we go. That's what I'm looking for. That creates a new string object, V, that points to some, a new reference V that points to a string hollow. That's now independent of the original Halloween. So even if the original Halloween disappears because it gets garbage collected away, this new string will still exist. So they're independent. It's created a new one. This is going to hang around until it gets garbage collected away on its own. But essentially, even when, let's go through animations quickly, even when this disappears, this is completely independent. Oh, okay. Other questions or comments about this slide? What about this slide? Okay, so we good on this slide? Yes?
Can the day be because of the day, you put a number? Can you put a number instead?
Where, here?
No, not where? Yeah. So like if it's an index does it have to be a word or?
The question was, what kind of parameters can be passed the index of? And the way index of works is the first parameter must be a string. That's the substring that you're looking for. It's looking for day in either what was Groundhog Day or what was May Day. And then the second parameter can either be there or not, but if it's there, it needs to be an integer, saying what position to start. Okay. So let's look at this code. This is a similar thing, but we're doing it with rectangles. We're going to create a whole slew. We're going to create two rectangles, the second one of which is final, and then play around with them a bit. The rectangle r equals new rectangle. Notice now I've created a rectangle and I have nothing in between my parentheses. So there you've not told Java any of the stats about creating the rectangle. It doesn't know how wide to make it, how tall to make it, or where to place it. In that case, Java will create a rectangle and set everything to 0, because it doesn't know what else to do. So when you don't put, the way rectangle behaves, and this is specific to the rectangle class, if there are no parameters in the parentheses, it creates a rectangle of all zeros. 0 width, 0 height, x is 0, y is 0. Then I create a new rectangle, S, and there I tell it the width and the height. And here, x and y is the width. I'm sorry, x and y is 3 and 4, the first two parameters, and the height is 1 and 2. Notice also that S is final, so we have the padlock symbol there. Padlock symbol is just so that we remember what's what. R.setWidth 5. So start at R, follow the dot, and we're going to call setWidth and make it 5. Notice that the only thing that was modified, the value in R didn't change. It was pointing to this particular object before that was called and after it was called. The only thing that changed is width was modified. R.setHeight 6 is going to do something similar. R.follow pointer, we're going to set the height equal to 6. Again, R hasn't changed, but what R points to has changed. Better way to explain it. R is still pointing to the exact same spot in memory, but the data at that spot in memory has now been modified. S.setWidth 7. We start at S, follow the reference, and we're going to set the width to 7. Notice that S is final, but we still were able to modify the object it points to. The value in S, which is a memory address, right, it's a reference, was the same before and after setWidth was called. But after setWidth was called, the data at that spot in memory has been changed. So this is what we mean when we talk about how you can't change, when a reference is final, the address in that reference or where it points in memory can never be changed. But what's at that point in memory can be modified, such as by calling setWidth. R equals new rectangle 10, 11, 8, 9. Creates a new rectangle. It makes R point to it. And then this rectangle gets garbage collected away. So now here, that's just saying I'm going to make this reference point to some new rectangle that I've created. Nothing points to this, so it just disappears. And let's say S equals new rectangle 12, 13, 14, 15. What that's doing is it's trying to make this reference point somewhere else. And Java won't allow that. Because there you're actually trying to modify the value in the reference, and that reference is final. You can modify what it points to, meaning what's actually at the location it points to, but you can't modify where it points. So Java won't allow that. So the question was asked about strings. There are certain methods they're called mutator methods. But essentially, they allow you to modify an object. When I call setWidth and setHeight, that's modifying certain values of the object. Setwidth 5, setwidth 6, setwidth 5, setHeight 6, setwidth 7. Those are methods that allow you to, it doesn't change where that object is in memory, but allows you to modify that object. And you can call those on a reference that is not final or a reference that is final. So that's what we did here. And the question was asked, well, why not, how does this work with string objects? For various reasons, it so happens that the string class does not have any mutator methods. So I couldn't really show this with strings, because what I was trying to show is that you can call your mutator methods out of either type of reference, a final or a non-final. But string objects don't have any mutator methods. They were not designed with any. Just because that makes Java run slightly faster. That actually is the real reason they did it. So this is why I actually showed this example with rectangles. Question?
Okay, so the last line there, it doesn't work just because it's changing the address.
Mm-hmm. Okay. It's changing the value. Excuse me. What's final here is S, which is a memory address, and this last line is trying to change that value. Okay. Not sure why this slide is there. We talked about that, right? We've talked about all that before. Somehow that slide got mixed up with all the others. Right. So, one last scanner usage example. Scanner standard in equals new scanner system.in. Again, it creates the scanner object. That's a shorthand representation. And every time I call a method, actually no, we saw the slide, didn't we? Yeah, but that's what memory looks like after that. Int x is creating an x variable. The value that's going to be stored in that x variable, from the standard in scanner, we're going to call the nextInt method. It's going to go do whatever it needs to do and give us a value, an int back. Well, it so happens that what it does is it queries the keyboard for a value. It gives us that value back, and we store it in x. Similarly with double D. This next double method does whatever it needs to do, query the keyboard, and it gives us a value back, which we store in D. Also for S, we're creating the reference S on the left side of the equal sign. And here we're telling standardin.next, or the next method in the scanner, to go create an object, a string object, and this S is going to point to that string object. It so happens that the way it creates the string object is it reads it in from the keyboard. But the idea here is that we're still creating an S reference, which is pointing to some string object. Hello world.
What if for double D and for int we used just next and then parentheses? What would that do?
So if you did that?
Yeah.
So the question is what happens? So if you try doing something like that, where you just call next for int x and next for double d, Java's going to complain. Because what happens is it sees on the right of the assignment a string, because standard in.next returns a string, and it sees on the left an int. And Java doesn't know how to convert a string to an int. There are ways to explicitly do that conversion, and you can tell Java to do it. But it's actually it's not a cast, that still doesn't work. But here, because it sees a object on the right, specifically a string object, it doesn't know how to convert it to an int. So Java wouldn't allow that.
So just putting next parentheses returns
gives you a string. Just the next method and the next line method, we're going to kind of ignore the next line method in this course, just gives us a string.
So next is the same as next line?
The question was, is next the same as next line? They're pretty similar in how they work. The difference is whether or not they capture the return at the end of the line. Next line does, next doesn't. The difference, it ends up being really confusing which one to use, and they're kind of finicky in their behavior. So we'll always be telling you which one to use, and most of the time will actually be next. Okay. So we talked about the Ig Nobel Prizes last time, and we did the 2004 version, and I thought I'd go over the 2002 version. And every year when they come out, so for those who weren't here on Friday, the Ig Nobel Prizes are given out about the week before the Nobel Prizes in such esteemed categories as you see here. And you'll notice that some of these categories are not normal prize categories, such as hygiene. So biology, courtship behavior of ostriches towards humans under farming conditions in Britain. This was an actual article that somebody published. Physics, demonstration of the exponential law of decay using beer froth. So they pour themselves a beer, watch the head go down, drank it. Pour themselves another beer, watch the head go down, drank it. Interdisciplinary, a comprehensive study of human belly button lint. That's not what my research is. Chemistry. I'm sorry?
Is this where our funding money goes into?
You know, the question was, is this where our funding money goes into? No. I think a lot of these, well, some of these, I don't know, some of these might be more interesting than others, but I think a lot of these are just people who do this anyway and try to publish an article, probably fund themselves. So interdisciplinary, this one person created a four-legged periodic table. So there's an actual wooden table with different cells. And in each cell was the actual elements at that spot in the table. Of course, some elements like, uranium and plutonium, you kind of die if you sit at a table that's filled with them. So it wasn't actually in the table, but he got, argon and hydrogen and helium and all the other elements and actually put them in containers inside the table. Mathematics, an article called Estimation of the Surface Area of African Elephants. Literature, the effects of pre-existing inappropriate highlighting on reading comprehension. Which, for those of you who've gotten used books, you know exactly what that's about. Peace, for creating Bowlingual, a computerized dog-to-human translation device. Since you've never heard of it, you can imagine that it didn't work very well. Hygiene, for creating a washing machine for cats and dogs. The head sort of sticks out and the washing machine goes around them. Economics, Enron, Arthur Andersen, and various other companies for applying imaginary numbers to the real world. In medicine, it was male asymmetry in man in ancient sculpture. Yeah, I'll just leave it at that. Okay. We're now going to talk a bit about overloading. And I should be able to get through this in the next 5 minutes. So consider the plus operator. The plus operator does a whole slew of things. It does integer addition, 3 plus 5 equals 8. It does floating point addition, 3.0 plus 5.0 equals 8.0. Although you and I might think of this as the same thing, a computer doesn't. There's actually different parts of the CPU that does integer addition and floating point addition. It also can take two strings and stick them together. So here the plus operator does many things. And if you assign a certain task to an operator, such as integer addition, you are giving it a load. And if you assign multiple tasks to it, you're overloading it. I didn't come up with the terminology. But the point here is that the plus operator is overloaded, meaning it can do many different things. Integer addition, floating point addition, string concatenation. So, we've seen a whole slew of methods. In the string class, for example, we've seen char@, substring, index of. And it turns out, rectangle class, right. So let's look at the substring method in the string class. The substring method, one version can just take a single integer. And it starts at that position, and of course, strings start at 0, so that's really starting at the fourth character, and returns the string from that position to the end of the string. I guess from your point of view, it's from that position to the end of the string. That's one version of the substring. So that returns everything from the fourth character on until it hits the end of the string. There's also the version that takes in two ints. Starts at 3 and goes up to but not including 6. So that's going to return a string of length 3 because it returns the characters at indexes 3, 4, and 5. So notice here that the substring method has multiple meanings. It can do many different things. Well, okay, it can do two things. But it can do multiple things. So we could say that, or we do say that this method is overloaded, meaning it has multiple functionalities that it can perform. Just like the plus operator can do many different things, the substring operator can do many different things as well. So remember on a previous slide, I had two versions of the index of method. And the index of method, one takes in just a single string and it searches for that string. The other takes in a string and a position, and it searches for the string starting at that position. The index of is also overloaded. So Java tells these apart by their parameter list. Somewhere in the bowels of the string class, there's two copies or two definitions for the substring method. One of which takes in a single int parameter, the other which takes in two int parameters. The way Java knows which is how many ints you stick in the parentheses. You stick in 2, it knows to do one version. If you stick in 1, it knows to do the other version. Right. The substring method can take 1 or 2 parameters. So, the value of method, and we saw this about a dozen slides ago. It also has many different versions of that method. In particular, we could say string.value of 3. We are passing in an int parameter. String.value of 3.5. We're passing in a double parameter. String.value of, and that's sending in the character 3. We're sending in a character parameter. Turns out for each of the primitive types, there's a separate value of method. So there's a total of 8 of them. Actually, I think there's 1 or 2 extra. So here we have close to a dozen, okay, I'm rounding up, close to a dozen different versions of the value of method. And we could certainly say that this is overloaded. And the way Java knows which one you want is by the parameter list. If you send in an int as a parameter, it looks for the int version of it. If you send in a double, it looks for a double version. Okay, I think I'm out of time, and I'm going to